So today, I'm going to be talking about microservices, monoliths, and everything in between. So my name is Sarah Griffs. I am Director of Engineering at Slice. We are a company in New York that empowers small pizzerias through technologies. We have about 8,000 pizzerias across the US, and we work to help the small guys and gals compete against big pizza. This is the Papa John's, Pizza Hut, Domino's of the world. So I joined Slice after it had been running for about 8 years on a monolith. So this talk is inspired by my experiences at Slice and the work my team and I did to move to more reasonably sized services. So I'm going to go through the history of monoliths, and then we'll talk about the trend into microservices, and then I'll talk about how at Slice we use just right services in real life for real business and product needs. And finally, we'll answer the question that you all are probably asking yourself, which is, what size fits my needs? What size do you need to use given the state of your engineering team and product needs? So what is a monolith? To get at the definition of a monolith, we need to understand the history that precedes our current notion. And this starts all the way back in the era of mainframes. Early mainframe programs were very much monolithic, where everything was managed by one huge program with no separation of layers. So this included a UI, application code, and access to the data, the database, all in one system. This evolved into two-tier applications where UI and app code were coupled. The access to the data was no longer straight on the file system, but in a database. And this structure took advantage of databases as they became fully fledged products. Then, in the dawn of the PC era and internet, we evolved into three-tiered applications where there was a UI separate from an app and separate from a database. And because we had this PC and internet, you can think about it as the UI was able to run in the browser, the server could handle the back end, and the database could still be separate like in previous architectures. And this was really the beginning of the front end and back end split that we're familiar with today. So again, getting at the definition of a monolith, even in the era of mainframes, the definition was a moving target. The definition can't be described by the individual components of the architecture, but is much more a description of the constraints of the system and the technology environment that are ever changing. So this means that it's contextual. In general, I think we can say that if you're using something that is less modular than other readily available technologies in use, it can be considered a monolith. So it's important for us to come to a definition of what a monolith is in 2018. Nowadays, that can easily mean an application where the UI and the app code are bundled together. It may even mean a server app that's bundled together, since people have started breaking different functionality off their single app into many small server-side apps. And I think I would say that this is the current definition of microservices. Another thing that's important to note that we won't get into a lot today is the trend towards serverless. Serverless apps tend to have single isolated functions. And I think it's worth noting that in the future, we may even consider our current version of microservices to be monoliths compared to this serverless architecture. So that's probably the definition of a monolith in 2018. So let's talk about the definition of a microservice in 2018. Well, this really means we're talking about a service-oriented architecture. In the monolith on the left, we have all server-side app code bundle. There aren't any standalone services. With the microservices on the right, this is a service-oriented architecture where we have multiple apps supporting a UI. And these could be things like an order service, an authentication service, or some other unit of functionality that we deem worthy to be its own service. Now that we have a more precise definition of what a monolith and microservice look like in 2018, we can talk about the pros and cons. So let's talk about monolith pros, because there's not a one-size-fits-all pattern. It very much depends on the context of your engineering org, and as we'll see later on, you can use these pros and cons in a framework to determine what's right for you. So in a monolith, we have a simplified architecture. This makes it easier to wrap your head around. People generally start with a monolith because they start with an idea, and it's more important to create a working MVP than it is scalable architecture. You need to be able to vet your idea first. You have easier deployments. You know all code is going out at once. You don't have to worry about things like deployment order, deploying one service before another service. And in general, there's less complexity. So you know all of the dependencies from deploys. You can look at all of the code in one place. And this can be very good for an engineering organization that has few developers. It's also important to note that a monolith can be faster because there's no network calls between microservices, which is how a lot of microservices and service-oriented architectures speak to each other. But a monolith has a lot of cons. To name a few, it can be hard to maintain. Tech debt can easily accrue over time. Unused code can add up to something that feels stale. And this may be because you're using a language that's out of date, a framework that's no longer useful, old practices that are out of date, and perhaps there's not a lot of turnover in the code. You also lose out on reusability. It's hard to reuse the monolith itself and even pieces of it because they aren't isolated. It's probably rare that one developer understands the entirety of the monolith, and this can make it hard for the entire engineering team. You lose out on the ability to choose the right tool for the right job. And the main reason that we see people moving from a traditional 2018 monolith to microservices is that they don't have the operational agility. So if you want small pieces to work on one piece of the app, that can be hard in a monolith. It can become a bottleneck. If you have 5 people on a team working on a monolith, may increase transparency and efficiency, but if you have 100, it becomes very difficult to coordinate the release of work. What are the pros of microservices? Microservices are easier to scale. It makes sense for scalability. So if you have an area of your application that gets a lot of traffic, you can scale that area of the application versus the entire system. It makes it easy to understand. A microservice is something that's easy to understand, and you can profile that specific component for performance. So this may be something like a payment service or user authentication service, where you can load test a component, look at the performance of that component. Along those lines, it's easy to make isolated changes, and you can move quickly on independent pieces. If you have a microservice, changes to this service only affect that service and not the entire system. So if this service goes down, there's some sort of issue with it, it only affects this service and not your entire system. You can reuse components in a microservice world in service-oriented architecture, where let's say you're building a new product, you can take pieces from your services and create a new product using the things you already have. And finally, in microservices, you can use the right tool for the right job. You choose the right language, the right framework that works for what you're working on. But the cons of microservices are that they're hard to understand the entire system, because you might have a dependency tree that gets way out of hand. And this means that you have to be very coordinated for development and for deployments. But in microservices, your operational cost to maintain and develop microservices is prohibitive for most organizations, and it's probably unnecessary for most organizations under a certain size. And it's important that if you're thinking about moving into microservices, you don't do it too soon, because if you have ill-defined architectural boundaries in your services, it can lead to Conway's law in a very negative sense. It can lead to unstable ways that while the team and company are growing, the services may define the team may define the services, and you lose that symbiosis. So we've gone over a lot of theory, hypotheticals, but I'd like to get into some concrete examples now, and go through 5 examples of what just right services look like based off of the team I look and I did at Slice. Some fit a more modern definition of a microservice, but I think all of them fit within the needs and constraints that we had at the time. So enter Slice, which was then called My Pizza. It was running 7 years on a monolith with one developer who was our co-founder. My Pizza landed a seed round, which allowed them to hire developers. And this led to a spike around awareness on the product, which led to more traffic and ultimately led to more pressure on this monolithic system. The places where there are extra pressure, we felt like we could improve. And that's why we started pulling chunks of the monolith off of the monolith to form smaller services. And I wouldn't say that these are microservices by the 2018 definition of microservices, but they were more predicated by common sense and our business needs. So we first started considering the performance of our backend, and we needed something much more robust for the launch of our iOS application that was using this backend. Started with this ancient consumer-facing monolith, and the API on this monolith couldn't be scaled independently. Our deployments were unstable as the pipelines around them were new, and any downtime in this legacy monolith had a huge customer impact. Our team size was about 5, and our skill set was very low in the infrastructure side. We only had 1 DevOps engineer. These are probably reasons to stay monolithic. It's hard to split things from an understanding the system and operational point of view, but we did have strong product and business needs. This functionality we wanted to isolate from the current monolith, web orders and order processing, and have it only be supporting client-side applications like our iOS app. There are also strong reasons on the engineering side where we wanted to scale and deploy this backend independently. And it fit into the overall architectural plan of our engineering organization, which we had decided was to break apart this monolith. So ultimately, we created a core API, which allowed us to move fast with something that we could dedicate resources to, and was our first right-sized service. I wouldn't say this fit the definition of a 2018 microservice because it was more of a separate API monolith. So with the launch of our first API-only app, we could easily plug other client-side systems into our core functionality. We scored a major partnership with Facebook, which would allow consumers to order from pizzerias directly on shop Facebook pages. This was right around the time of finishing our first internal core API, so it made a lot of sense to leverage that work in working on this Facebook project. So we were still a team size of 5, and we still only had 1 DevOps engineer. And again, I would say these are reasons to stay in a monolith. You don't want to split off from your monolith too early, and operational costs can be high for a small team. But there were strong product and business reasons to split. This was very clearly isolated functionality. It was functionality specific to Facebook. And similar to the core API, we wanted this service to scale and deploy independently in accordance to traffic from Facebook, which could follow a very different traffic pattern than the rest of our services. And given that our architectural plan was still to break apart this monolith, it made sense to make our second service a right-sized service. So we created a partnership API. We launched this service and continue to support the Facebook partnership through this service to this day. So fast forward a year or so, and we rebranded from My Pizza to Slice. The business grew up a lot, and we continued our trend to moving into microservices. We have an Android and tablet app that accompanied the iOS launch, and we have many more services, the sizes of which are based on different criteria. The engineering department is split into 3 squads based on the 3 business verticals that have emerged over the past year. The first squad is mostly for internal support to customer service and our order processing team, but much of the old monolithic business logic lives here. The second is consumer-facing, including our mobile and web apps. And the third is restaurant-facing tech, and this is the team that I was leading. We wanted an owner's portal to view business analytics. When we wanted to design it in a way that would provide an advantage to business owners and allow them to understand their business better. And this is the first app catered to the other half of the Slice client base. What this means is that Slice is interesting because Our clients aren't just the customers that order pizza, but are also the restaurant owners. So restaurant owners wanted a very data-driven app, and we knew we could get this data from, which was already available through our APIs. So this app had a lot of unique data requirements that the other apps did not. At this point, our team size was a bit bigger, 15 or so, allowing some flexibility on working on different products and projects. We had stronger React engineers. These things leading to allowing more microservices. We had a strong product need that this product could easily be isolated from our consumer-facing services and really didn't need the same functionality as our consumer-facing services. And from an engineering perspective, since we already had the data available to us through APIs, we can leverage that. Our architectural plan was still to break apart the monolith, but we only had one DevOps engineer. But because as a team, we had chosen to go down a path where new services like this internal API and Facebook API needed to be spun up quickly, he had built a system capable of slinging services out in a fully productionalized capacity, including auto-scaling, monitoring, and logging. So all of these factors made it evident that a front-end monolith in React made sense. So all of our business owner analytics lived in this front-end monolith. We continued to look at what was important to business owners and their success. And for any business nowadays, that means a website and a strong homepage. We have 8,000 domains of pizzerias across the country. And for Slice, these domains are very important because they drive 50% of our organic traffic and are part of our Google My Business program. And the success of these pages very much impacts our revenue. Since these pages are landing pages where a lot of organic traffic comes in, we need strong SEO. When Google announced that HTTPS would be prioritized over non-HTTPS when determining SEO rankings, we knew that we needed SSL certificates on 8,000 domains. At this point, our team size was a little bit larger, probably about 20. Our skill set was roughly the same. From a product and business need, we knew that the cost of certificates alone could be millions, let alone the cost of implementing and maintaining all of these certificates by hand. From an engineering perspective, there were a lot of moving parts around keeping SSL certs up to date, and it was clear that didn't rely on